Exponential growth and decay. Okay, first of all, we have to find the general formula in order to solve these kinds of exercises. And now, the basic principle is that we have to find a differential equation that it's a function of time whose rate of growth at any time is directly proportional to the value of the function. This would be dy dt, dt because it's time, is equal to ky. K because it's a constant and it's directly proportional. Now we have to integrate this function, and the first step would be to pass the y to the y and the t to the k. So 1 over y dy is equal to k dt. Now we integrate this function. So y, the integral of 1 over y dy is equal to the integral of k dt. This would be ln, absolute value of y, is equal to kt plus c. Now we e both sides, and it's going to be e to the ln, absolute value of y, is equal to e to the kt plus c. This would be absolute value of y is equal to e to the c times e to the kt. Now, in this formula, we don't take into account the absolute value, so it would be y is equal to c times e to the kt, k being the constant of growth. Now, this formula can be used in real-life situations by finding the rate of growth of microorganisms, or in order to find the half-life of elements such as carbon-14, or in the exercise that we're about to solve. Okay, a bacteria culture grows with constant relative growth rate. The bacteria count was 400 after 2 hours and 25,600 after 6 hours. First, let's solve A. What is the relative growth rate? Okay, so we have that the general formula is y is equal to c e to the kt. Okay, now we have to find the relative growth rate, which is k. To do this, we have to take into account these pieces of information we have: 400 after 2 hours and 25,600 after 6 hours. And we plug in the numbers in two separate equations. So it would be 400, the value of y, is equal to c times e to the 2k. 2 because it's after 2 hours. And on the other side, it would be 25,600, the value of y, is equal to c times e to the 6k. 6 because it's after 6 hours. And then we solve for c. So it would be 400 over e to the 2k is equal to c. And on this side, c is equal to 25,600 all over 6e to the 6k. We do this so we can solve for k. Now, this would be 400 all over e to the 2k is equal to 25,600 all over e to the 6k. So e to the 6k all over e to the 2k is equal to 25,600 over 400. This would be e to the 4k is equal to 64. Now we ln both sides, and we get that 4k is equal to the ln of 64. Now we solve for k, and k is equal to ln of 64 all over 4. Now you have to state your answer in a full sentence, and it would be the relative growth rate is ln of 64 all over 4. Now let's solve B. What was the initial size of the culture? So in the general formula, the initial size would be c, so we're trying to find c. Now we have these values that we can plug in to the formula. You can use 402 or 25,606. I'm gonna use 402. So 400 is equal to c times e to the 2 hours, times the value of k, which we just determined. So ln 64 all over 4. Now we solve for c. So 400 is equal to c times e to the ln of 64 all over 2. Now c is equal to 400 all over e to the ln of 64 all over 2. And if we plug in these numbers in the calculator, we could get that c is equal to 50. Now in a full sentence, the initial size of the culture was 50. Now let's go to c. Find an expression for the number of bacteria after t hours. So this would be a general equation for this example. We have the value of c, 50, we just determined it, and the value of k, ln of 64 all over 4, which we determined in exercise A. So we have that y is equal to 50 e k ln 64 over 4 times t. Okay. Now let's go to D. Find the number of cells after 4.5 hours. So in this one we just have the general formula. We just determined it. Here it is. So now we just have to plug in the 4.5 hours and the t, the value of t. So it would be y is equal to 50 times e to the ln of 64 over 4 times 4.5. And we plug the numbers in our calculators and we get that y is equal to 5,381.7, which is more or less 5,382. So in full sentence it would be the number of cells after 4.5 hours is 5,382. And now the last part of the exercise. E. When will the population reach 50,000? So we have the general formula, and now we have the value of y. We're missing the value of t. So 50,000 is equal to 50 times e to the ln 64 all over 4 times t. We're looking for t. So we divide by 50, which is 1,000 is equal to e to the ln of 64 over 4 times t. Now we have we ln both sides. Ln of 1,000 is equal to ln 64 over 4 times t. Multiply by 4, divide by ln of 64, and we get that 4 times ln of 1,000 all over ln of 64 is equal to t. And t would be 6.6439 hours. Now, if we want to state this in a full sentence, we can leave it like that. We have to write it in hours and minutes. So it would be 6 hours and 60% of the other hour, which would be 40 minutes. And that would be the answer. And in full sentence, it would be the population will reach 50,000 after 6 hours and 38 minutes, 40 minutes.